Now we expect that alkali metals are going to be very reactive. After all, they're over here in group 1 of the periodic table. Very easy for them to give up an electron, forming themselves as a cation, single plus one charge, while giving an electron away to something else. That's what we're expecting to see whenever we throw alkali metals into some sort of reaction. Now, that means really at heart, any of these metal reactions from the alkali metals are going to end up being electron transfer reactions. So electron transfer reactions are the big category they fall within, and alkali metal reactions are the ones that we talk about in the TRO textbook. Now, suppose that we take two atoms of sodium metal and we place them into chlorine gas. Well, here's what's going to happen. We're actually going to see a flame appear as these two react. It's a very exothermic reaction. They're going to react very quickly, and they're actually going to form Na plus and Cl minus. We'll have two of each, of course. Now, really what you're saying is sodium is so good at giving up an electron. It gave an electron over here to the Cl molecule. Now keep in mind that this is what the Cl molecule looks like as far as the Lewis structure goes. Now what you're saying here is, suppose we gave it two extra electrons. One from this sodium atom, popping in right here, and another from the other sodium atom popping in right there. Well, remember that this shared pair of electrons in the bond was also one electron and one electron. So now they can just completely sever and flow their separate ways as two Cl minus ions, or chloride ions. They're going to be paired up with those two Na plus ions that just formed. Now, of course, these two are going to attract each other immediately. I mean, they were bumping into each other to react in the first place. They don't get very far away. They're going to stick right together. And so the product of that reaction is going to be NaCl, which is going to be a solid. We'll get two of those. And so what you'll actually see if you were to do this reaction is that hot flame that I mentioned, not a combustion reaction. We don't have the right products and reactants for that. But a hot flame, and instead of it creating smoke, what you actually see are very fine particles of sodium chloride that are forming and settling out at the bottom of the vessel. You can search around online and you'll get to see one of those reactions pretty easily. That's the kind of thing we're talking about for an alkali metal reaction with a halogen or in the gas phase. But what if we were talking about something that's in water? What's going to happen is the sodium atom is actually going to donate an electron to the water, and it's going to tear the water molecule apart. And out of that, you're going to form hydrogen gas and hydroxide ion that'll stay dissolved in the water, which will also form a whole lot of heat. So let's write one of those reactions out here so you can see what's going to happen, and we can explain a little bit about what's really going on at the micro scale. So if we have, let's just stick with sodium metal, and let's have two of those. And we're going to have two water molecules that it's going to react with. They're going to form H2 gas, and they're going to form OH minus, and they're going to form Na plus. So notice Na plus and OH minus. We could summarize that as saying NaOH, right? So that's what we're forming. We're forming sodium hydroxide. And sodium hydroxide is one of our strong bases that we'll be memorizing. And this is something that's very effective at creating a basic environment in water. Now, I'll write here that it's aqueous, and that's actually telling me that it's going to be dissolved. And so from that, we actually do still have, floating around in the solution, we have the Na plus ion, and separately we have the OH minus ion, but we'll write it as NaOH, aqueous, which is just shorthand for what I just did right there. So we tore apart the water molecule. By severing one of these bonds, by giving an extra electron over here to the O on the OH, that created the OH minus. Left behind a hydrogen with a single electron. So it found another hydrogen with a single electron in that process. They get together and they share that pair of electrons to make a bond. And that's how we ended up with the hydrogen gas that you see here. Now, funny thing about this reaction though, I've just created a ton of heat, and we'll talk about that in thermochemistry, and I formed hydrogen gas that's now bubbling out of the solution. I should be able to light that on fire with a match, or the heat should be enough that it actually catches fire on its own, which is one of the reasons that you hear that if you throw sodium metal or any of the alkali metals into water, it's going to explode. It's not that the metal itself is exploding. The metal itself is creating a really basic solution. Separately from that, and in the same process, it's creating hydrogen gas and lots of heat, and that heat causes the H2 to ignite. That's what we're talking about with most of our alkali metal reactions.